All right, so today we are going to talk about a type of math called modular arithmetic. And it's actually a style of math that you know very well, even though it may sound like a big fancy name. So we are going to start by considering a clock. All right, we all know our clocks. And what does it look like to add time? All right, so start off with an example. Let's say that it is 3 p.m. And we want to know what time is it if I add 10 hours. Okay. Well, okay, we can just use our basic, math. 3 plus 10, well, that's going to give me 13 p.m., right? Well, of course not. That's not how we do time in this country. What we do is we then loop things back around, and it's actually going to be 1 a.m. All right, so we end up looping around once we get to 12. Okay, so first things first, forget the AM, PM stuff. That's not important to what we're doing. All right, but what is important is the fact that when we're looking at a clock, 3 plus 10 is actually equal to 1. And this is a prime example of something called modular arithmetic, where the numbers wrap around once you get to 12. Okay, so first things first, some differences between a clock and the modular arithmetic that we are going to be using. First, in modular arithmetic, we always start at 0. All right, there's lots of reasons why we need a 0 in there. Clocks, the smallest number is a 1. In modular arithmetic, the smallest number is a 0. All right, so what I want to do now is actually look at my number line. All right, so on a number line, we've got 0, 1, 2, 3, 4, 5, 6, bear with me now, 7, 8, 9, 10, 11. Okay. Now in modular arithmetic, so up here at the top, we've got the numbers that we know and love. Okay, this is our basic number line. In modular arithmetic, all right, the numbers between 0 and 11 end up being the same, okay? At least when we're working on wrapping around 12 here. But once we get to 12, what we're going to do is we are actually going to wrap back around to the beginning, to 0. And so when we get to 12, all right, so 11 plus 1 is actually going to be 0. The next number after 11 is 0 because we're going to wrap back around to 0. And then the next number is 1, 2, 3, and we keep on going until we get to the next 11, which will be down here at 23. All right, and then when we get to 24, in modular arithmetic, we would wrap back around to 0. And going in the negative numbers works just the way that you would think it would at this point. If I go to the left of 0 by 1, I normally get negative 1. I normally get negative 1. But in modular arithmetic, what I'm going to do is I'm going to, all right, so these two zeros are basically considered the same. So if I take this 0 and move to the left 1 unit, I get 11. And then if I move to the left 1 more unit, I get 10. And then I get 9. So what this means is that negative 1 is the same thing as 11 when I'm working in this wraparound way, and negative 2 is the same thing as 10. All right, and 14 is the same thing as 2, and 23 is the same thing as 11, and 24 is the same thing as 0. All right, so what this has a lot of different implications. First, in modular arithmetic, at least when we're wrapping around 12, we only use the numbers 0, 1, 2, 3, up through 11. All right, those are basically the only numbers that exist. And any other numbers that exist out there are equivalent to one of these numbers, all right, in the same way that 15 is equivalent to 3, and negative 2 is equivalent to 10. All right, the last thing is notation, because if I start writing things down like 14 is equal to 2, anybody who reads my work is going to think that I am completely crazy or don't know math at all. So we need some notation to indicate that we are working in modular arithmetic, and in particular that we are wrapping around the number 12. So the way that we write this is 14 mod 12 is equal to 2. All right, so we add this mod 12 in parentheses to state that, okay, we are wrapping our numbers once we get to the number 12. And so in that case, 14 mod 12 equals 2 is a mathematical sentence that makes complete sense. And you can also say things like 3 plus 10 mod 12 is equal to 1. All right, because normally 3 plus 10 is 13, and 13 mod 12 is equal to 1. All right. So this is a lot of information. I'm going to throw a little bit more at you, because we can look at different mods. All right, we did everything mod 12. That's how we would talk about that. The fact that we're wrapping around the number 12 means that we are working in mod 12. But there's nothing special about the number 12. We could use different numbers, and in fact we will. And so ask a question. What is 5 mod 3? All right, so now we're wrapping around the number 3. What is 5 mod 3? So pause the video, think about this for a sec. Try and come up with an answer. Doesn't matter if it's right or wrong. But try and think about it, and from what you know, what do you think the answer is going to be? And why do you think that is the answer? All right, so to look at this, we're going to go back to the number line, all right, for right now at least. 0, 1, 2, 3, 4, 5. And we'll go 6 and 7 just for kicks. Okay, so the top line is the regular numbers. On the bottom, we are going to use the mod 3 numbers. So 0, 1, 2, and those are the only numbers that really exist mod 3. All right, and we can see this because when we did mod 12, the numbers that existed were 0 up to 11. So when we do mod 3, the numbers that exist should be 0 up to 2, 1 minus 3. And then we keep repeating 0, 1, 2, 0, 1, da da da. So to figure out what 5 mod 3 is, well, the 5 and the 2 seem to be equivalent with each other. So 5 mod 3 is equal to 2. Okay, so hopefully you're getting an understanding of this, but we don't want to have to write down the number line every single time that we do this. So how can we try and figure this out without writing down the number line? And what we can do is we can really think about this question. How far is 5 above a multiple of 3? All right, so sort of what is the distance of 5 from the nearest multiple of 3 that is below 5? Okay, so let's take a look at our number line. But this is something that we can generally do in our heads, as long as it's not too big of a number. So we have 5 here. What's the nearest multiple of 3 that's below it? Well, apologize. 3. All right, so what is the distance of 3 to 5? Well, 2. All right, you have to move 2 integers to get from 3 to 5. So the answer to that question is going to tell you what 5 mod 3 actually is. All right, so now let's do 22 mod 3. All right, so let's look at 22. What is the nearest multiple of 3 to that? And then how far away is it? All right, so the nearest multiple that's below it, at least, is going to be 21. All right, 21 is a multiple of 3, and 22 is 1 unit away. So 22 mod 3 is going to be 1. All right, we'll do one more. 3 mod 3. All right, how far away is 3 from a multiple of 3? Well, 0, because 3 is a multiple of 3. So all multiples of 3 are actually going to be 0 when we consider them in mod 3. All right, and so last bit, and this one's really important. What is 5 plus 22? Mod 3. All right, and so there's actually 2 ways that you can do this. We could add 5 and 22. All right, that gives us 27 mod 3. 27 is a multiple of 3. All right, so it's 0 units away from a multiple of 3. All right, so the answer is going to be 0. But there's another way that we can do this. And what that is we can actually replace the 5 with what it is, mod 3. All right, so replace it with a 2, and replace the 22 with what it is, mod 3. All right, so the 22 becomes a 1. All right, and so now 5 plus 22 turns into 2 plus 1, mod 3. And that's a really easy calculation to do. That's 3 mod 3, and we already know that that is 0. And so we see, oh, hey, these two are the same answer. All right, and they always will be. So when you're doing addition, sometimes it's going to be a lot easier to take the various components of the addition and reduce them down to what they are, mod 3 or mod 5 or mod 26, whatever we happen to be using, and then do the addition, rather than trying to add possibly 2 big numbers together to get an even bigger number and then figure out how far away that is from a multiple of 3. All right, so that is the beginning of modular arithmetic. Next time we're going to talk about negative numbers and subtraction. We're going to talk about multiplication, and we're going to sort of talk about division of modular arithmetic. All right, so see you next time.